Welcome back to another installment on multiplying exponents. Without further delay, let's get started. We know c squared equals 15. What's the value of c power 4? I don't think the problem could get any easier. So we know we have c squared equals 15. And we want what is c power 4. Okay, it's better you focus on c power 4 because we already know what c squared is. C power 4 can be written as c squared over raised to the power 2, right? Because a power m raised to the power n is a power m times n. So we are essentially working backwards. We've done a few problems like this. So essentially c squared raised to the power 2 equals, so we know c squared is 15. So 15 squared is, I think it is 225. I should have known that, but since I've done this many problems, I guess you can give me a leeway that I'm allowed to forget what is 15 times 15. All right, if a and b are non-zero numbers such that a squared equals b cubed, until the following is equal to a power 6. Essentially what they're asking is all your answer choices, if this was a multiple choice, would be in terms of b, right? We know a squared equals b cubed, right? What is a power 6? That means you should have cubed it, right? Because think about it again, a power m raised to the power n is a power m times n, right? Only when it is a, we know already a squared, so something has to go in place of n. Only if n equals 3, that means a squared raised to the power 3 is a to the 6. That's how I got this, which means I should cube the other side as well. So a power 6 equals b power 9. So the answer is b power 9. If a and b are positive integers and 2 power 2a times 2 power 2b equals 16, what's the value of a plus b? Very, very simple problem. Both terms on the left side already have a base of 2. So 2 power 2a times 2 power 2b equals 16, the same as 2 power 2a plus 2b equals 16. Now we have to simplify the 16 further. So 2 power 2a plus 2b equals 2 power 4 because that's what 16 is. Because a power m equals a power n, m equals n, if you use that logic, then 2a plus 2b equals 4. If you take 2 out of the bracket, a plus b equals 4, then a plus b equals 2. Simple, isn't it? Right, let's continue. We have b times b power 4 times b power 7 and raised to the power 1/2 divided by b cubed times bx equals b power 5. All right, b is a non-negative, then what's the value of x? Let's actually write it in a conventional, well, I'm going to write it as square root because anything raised to the power 1/2 is a square root. So I'm just going to leave it this way and write it in this format. Why? Because you may even actually forget the half and start canceling out the b, because that's what people that designed these tests really wanted you to do. Okay, let's beat them in their own game. Equals b power 5, right? How do we get rid of the square root? We have to get rid of the square root, just like how we did in the root x problem. Only then we will be able to solve this problem. So it means we square on both sides. So b times b power 4 times b power 7 squared over b cubed times b power x squared equals b power 5 squared, right? So if you square and a square root, then that becomes, I'm just going to solve this problem here. I'm actually going to draw the line to separate out the previous problem. Let's go upstairs. So let's go up. So it's b times b power 4 times b power 7 over b power 6 times b power 2x equals b power 10. Do you see how I got all of these, right? B cubed raised to the 2 is b6. B power x raised to the power 2 is b power 2x. So now we can start canceling a bunch of b's. So this is b power, what is the overall thing on the top? 11 b power 12 over b power 6 times b power 2x equals b power 10. We can actually bring all of these to this side. So b power 12 equals b power 10 times b power 6 times b power 2x. That's b power 16 equals b power 2x, b power 12. Let's go again to the bottom somewhere here. Because the base, we can write one more step before we simplify it. That's same as 16 plus 2x, right? I could have done it right here, but I wanted to do it as a separate step. So we know the bases are same, so 12 equals 16 plus 2x. 2x equals -4, right? So x equals -2. It's a lengthy problem, but come on, it's not that difficult. The only thing you have to know, and the rest of the logics we've seen over and over, it's squaring both sides. That is the trick. As soon as you do that, it's like you're under cuffs, and as soon as the cuff is broken, you get all sorts of ideas what to do. So squaring on both sides is equivalent to that of a cuff, or a puzzle or a maze where you figure out that one thing and then it gets you going. It's that sort of moment. So once you figure out that square, and the only way you can do this, not by just doing one problem, maybe more than one problem. All right, this is another lengthy problem, but it's an easy problem. We have 7 power 8, okay, raised to the power n. And then we have 7 power 8 raised to the power 5, which is whole thing raised to the power squared, square root. Again, anytime you have a square root, you have to get out of the shackle by squaring on both sides. So 7 power 8 raised to the power n raised to the power squared equals 7 power 8 power 5. Now here's the problem. I would just simply substitute y equals 7 power 8 because it just looks like, okay, I don't know what I'm going to do. Once you substitute y, it looks like, oh, I'm familiar with this. You see? You're not going to do anything with a 7 over 8, so why not substitute it with y? This now becomes y power 2n equals y power 5. So 2n equals 5, so n equals 5 over 2. Now come back and substitute, 2n equals 5, n equals 5 over 2. That's it. We're done. They're only asking for value of n. Do you see how easy this problem is? But it could get difficult because you're not able to get out of that square root. And also the way they have written with all the brackets and stuff, it just looks like, oh my goodness, it's a difficult problem. But that's precisely what people write these tests want to do, and they will achieve their outcome if you fail that problem. You're essentially boosting their ego because essentially that's what they want to see you do. Now, the bottom problem is very simple. All you have to do is just, get these two terms together and these two terms together and just divide by y. So we have x cubed, that will be x power 7 net, 10 times x power 7 times y, plus this would be what, 7y squared total, and divide by y. If you have a plus b power m, the same as a power m plus b power m. That's the logic we have to use. It's not an exponent concept, but we've already used the exponent idea. This is just regular ratio. So that means it's 10 x power 7, 7y. That's the answer. Okay, these are the two last problems in this video. Which of the following is equal to 5 power 4 times 5 power 5 raised to the power 20? First, let's get what's inside the bracket to a one term. So a power m times a power n is a power m plus n. So 5 power 4 times 5 power 5 is 5 power 9, right? Because that is 5 power 4 plus 5. 5 power 9 raised to the power 20 is 5 power 9 times 20, which is 5 power, 180? That's it. Okay, whenever you have brackets like these, pay attention to what it is that you're doing. If you have 6 power 7 times 5 power 7 raised to the power. This is a very, very unique problem because the exponent power is the same. We can multiply the bases, which then becomes 30 power 7 raised to the power 7. Okay, this now becomes a power m raised to the power n is a power m times n. So that's 30 raised to the power 49. Very unique problem. Nevertheless, it's an easy problem. All right, consider subscribing to my channel if you haven't already done so. Thank you for watching. I'll see you with another video on multiplying exponents. Until then, bye-bye.